Hello, my name is Céline Bent. I'm from Amsterdam, the Netherlands, and I am the Compliance Director of buildingSMART International. The title compliance might be a bit confusing as it doesn't refer to compliance with internal policies or codes of conduct, but the buildingSMART compliance program is an insurance and quality trademark for openBIM. It promotes the education and certification for the effective deployment and confidence in using open standards and solutions. Its service that you might be familiar with, or you heard about it today already, is called professional certification. buildingSMART has developed a learning framework for training that can be accessed through buildingSMART's chapters. And after completion of such a training, an individual can do an exam on the practitioner, test your practical skills. So this is your actual openBIM driving exam. We are planning to launch other compliance services in the future, such as certification for openBIM on a project, for a company, a common data environment, and other objects of conformity. I will be here in the coming days. Please reach out to me if you'd like to learn more about this initiative and if you want to get involved, if you're not already. The reason that I was approached for this role had not much to do with my experience with openBIM or with BIM, but I believe more so with my experience in the field of compliance in the built assets industry for sustainability. There are many frameworks and ratings and certifications available and under development for sustainability. And you might be familiar with some of these. For a building, for example, there's a certification for sustainability, BREEAM and LEED. There's also sustainability certification for a company. B Corp, you might have heard of it, or conformity with the Science Based Targets initiative. And there's even a sustainability compliance for corporate reporting, such as GRI, the Global Reporting Initiative, or TCFD, which is a guideline for financial reporting on climate risks. I am very passionate about sustainability, and to be fair with you, I was initially hesitant to take on this role because I feared that my ability to influence sustainability in the built asset industry would be less significant by working on openBIM than in my previous role. But later, it became clear to me that by digitalizing the built environment, digitalizing the construction process, and better collaboration, they have an absolute significant effect on sustainability in the built environment. You might be familiar with all the negative impacts of the built asset industry, such as the loss of biodiversity and the depletion of natural resources and pollution and the violation of human rights, safety risks, and of course, the biggest current issue, climate change. I want to focus here on climate change and emissions in particular, the equivalent of CO2 emissions. And let's start with the building. One of the most well-known and tallest buildings on Earth is the Eiffel Tower. And recently, the president of France, Emmanuel Macron, has announced the symbolic example that it will turn off its lights an hour earlier than usual every day to save energy and therefore emissions. And this is, of course, praiseworthy of him, but it has also led to lots of criticism from French people and inhabitants of the City of Light, who are not supporting of this initiative at all. Well, let's compare this situation to someone who flies from, let's say, Amsterdam to Montreal. The emissions caused by the fuel usage from this plane can be compared to the emissions caused by the energy used for the lighting of the Eiffel Tower. And now let's take as a unit the emissions saved by turning off the Eiffel Tower's lights an hour earlier than usual on a day. If someone would choose not to fly from Amsterdam to Montreal and back, one person, the same emission savings would be achieved as by turning off the Eiffel Tower's lights for 200 days. And now, if we would cancel, let's say, a summit with about 200 people, with on average flying the same distance from Amsterdam to Montreal and back, the same emission savings would be achieved as by turning off the Eiffel Tower's lights every day until the year 2132. And this is including leap days. Clearly, flying causes lots of carbon emissions. But is this really an important part? Let's look at the global CO2 emissions. Then you see it's actually relatively small. So the aviation sector contributes 1.9% to all the global CO2 emissions. So apparently, we emit a lot of CO2 as humans by breathing out. All the animals participate as well. And then there's, of course, the built asset industry. Ladies and gentlemen, the built asset industry is responsible for 40% of all the global CO2 emissions. That's 20 times more than the CO2 emissions from all air traffic worldwide. And now let's take as an example the production of cement only causes 8% of all global CO2 emissions. So if we together somehow would be able to reduce the CO2 emissions of cement or reduce the production of cement by only a quarter, that would have the same effect as banning all the air traffic worldwide. So there is clearly so much more to gain. And by improving the built asset industry or making a small improvement in the built asset industry, this would be noticeable on a global scale. And by using open standards, interoperable solutions, we can impact the efficiency of the built asset industry on all the stages of a built asset's life cycle. For example, if you look at the design phase, IFC is used to produce very accurate and quick life cycle assessments. And this can influence design decisions in early stages. And with that, and by using building automation systems in the use phase of a built asset, that uses data from different sources, we can significantly reduce the energy consumption for heating and cooling and lighting in a building. And then, of course, the same solutions, they can help to increase the share of renewables used in the use phase of a building. And a disassembly manager or a demolition manager can allow for more reuse and recycling by using information from earlier phases of the design process. And a designer that designs the building with the end of life in mind, combined with the information from suppliers, can lead to increased disassembly and renovation. And aside from all these efficiency gains, obviously, the accurate measuring and recording thereof will lead to insights that lead to more knowledge, smarter buildings, and building smarter. So if we together, by improving efficiency in the built asset industry, would achieve an efficiency improvement from only 0.00002%, then we would at least have compensated for this entire summit. And with that idea, I'm standing here a bit more comfortably to introduce you the next speakers. Thank you. So our next speaker is the chairman of buildingSMART France, excuse me. He's also a board member of buildingSMART International. He is a director of the French Federation of Real Estate Developers. He has a wealth of experience in the construction and real estate development industries. He has been responsible for the construction of buildings that have received several very high sustainability ratings. And he's been involved in research on how you can use financial indicators for sustainability. Please welcome to the stage, Frank Hovorka.
Thank you. Thank you, Céline. Bonjour à toutes et à tous. Je peux parler en français, je suis à Montréal, donc je le fais avec grand plaisir. C'est un honneur et un plaisir pour moi d'être parmi vous au Québec. So it's a pleasure for me to be in Quebec, and I have a possibility to speak French with you, but as I understood, I have to speak English, so I will switch to English. So thank you again for the presentation, Céline. And well, you saw some numbers, and the question for me is, well, who gave the data? Who is giving the numbers? What's going on? Where it's coming from? Just to give you an example, Céline said that the built environment is 40% of the greenhouse gas emission. Well, it's an average worldwide. And you don't know what is inside. Is it only the energy in use, the embedded carbon, the link to the energy power plants? What is inside? So you have to go back to the IPCC works and the research, and you find out that, in fact, we are mixing often three metrics. One is about the building in use, the embodied carbon, and the life cycle assessment. And it's very important, and this is where I will try to go through with you. What are we talking about? Where are the data and what's going on? If we talk about greenhouse gas, if I look at the weight of each country, you see that China has the biggest. But it's not true, because a lot of greenhouse gas is emitted to build food goods that are imported then and exported to other countries, and this is the flow. So this is very important to have in mind, that when we are talking about greenhouse gas emission, whatever you think, it's something that you can't meter. There is only one meter, it's in Hawaii, and there they meter the level of particles per million in the atmosphere, and it's rising up. This is the only metering we have globally. We can't meter the greenhouse gas emission of the building. We can't. We can have assessment, we can have perimeter of calculation, we can have transformation of the energy into greenhouse gas emission by the weight of the energy, but this is not something we can meter. We have to calculate and manage data. Just to give you typical Sankey diagram of the flow, this is an interesting one because it's coming from final services that you can't see, but this is not the fact. It's really coming from the final services you are using, your thermal comfort in this room, and what kind of sector it's impacting, what kind of equipment is moving. Here it's certainly a handling unit and chiller and heating machines, and what kind of final energy we use, and which fuel and which emissions. If you do it at the level of a building, then it starts to be interesting because you can see where are the differences in terms of using. This is globally done worldwide. The same done for France. It's very easy to do. As you see, it's a very easy diagram from the primary energy to then the use and the carbon emission. So you see clearly that already we have several definitions, several ways of tapping the point, and it's very difficult when you are talking about greenhouse gas and kilogram of CO2 equivalent per person or per square meter. It's very difficult then to ask the people, what are you talking about? What is the perimeter you are asking? Where are you located? And what are you doing? And this is where I think we all in the room can have an important impact. Just to give you the gap between, for example, two ways of calculation that are usually mismatched. The one is the footprint. Your footprint is globally emission of the country. It means what you are emitting in the country plus what is the import. And you see the difference in France. It's quite huge because the import are 350 tons that you have to put back on the 660 tons. To be very clear, the Paris Agreement is based only on national declaration. It means only what you are doing and emitting in your country. Why? It's very easy to understand because they want to sum up all the national declaration and at the end of the day to have a global emission of the world. So they have to put away the emission that you import in your country. But if you look at your footprint, as Céline said, and your responsibility, you have also to look at your importation. And this is a second metric. So very careful, two metrics, my national declaration about what is in the country and the global footprint of what I have as an emission with my importation. And in France, just to give you the example, we are always saying that we are reducing the greenhouse gas emission in France. This is true, based on national declaration and emission in France. In the same time, we have increased the global footprint through importation. This is where we are good. We are good because we have a good number to say we are good. Matter of number. Well, you have understood that, I hope. So it was too easy. We invented a third methodology, the life cycle assessment. And the life cycle assessment is not made to calculate the carbon emission year by year or day by day. It was really smart approach to calculate the different possibility of design in a building or in an infrastructure. So you look at all the stages of life of your components from the product stage, use the construction process, use stage end of life, and you make a 50 years standardized lifespan. And you look at it and you say, well, if I put this kind of systems, this kind of products, what is the impact in greenhouse gas in my life cycle assessment? And of course, if you replace CO2 by euros, you have a global life cycle cost. This is also why it's important to do that, because you can then assess not only the greenhouse gas, but of course, the global life cycle cost of a building. So what we have done in Europe, and this is the use case I propose to go with you today. We have 9 directives under recast that will be applied into the member states, and what we call the taxonomy. So what is important in these directives? It's the target point is environmental, social, and governance approach, and ESG. So what is ESG? You see social, environmental, governance, and what do you find below? A lot of data. Because if you want to manage your performance, you have to manage a lot of data. And that's why Bloomberg, for example, is one of the advisors of the European Union for the ESG to work on data. Well, and if I look about how you can get the data, it's a mess. You have certifications, you have climate bonds, you have the corporate certification, but all this doesn't give you any data. It gives you a label, it gives you a quality system, but it doesn't give you data. And this is where we are with a problem, because we need to retrieve the data flow and the quality of information that is behind the building. So we need to go back to the quality of a building, to the performance of a building, to the list of products, to the list of components, to how behave the components in the building. Well, and what is really changing for us, because usually we are just in a closed room talking about design, construction, sometimes of giving an as-built documentation to the users. Well, things are changing in Europe, I mean. Because in Europe, we will have to go through a mandatory reporting system, which is this one. And this mandatory reporting system is mandatory for banks to give loans, it's mandatory for insurance companies, and it's mandatory for investors. So at this time, from next year, the banks will ask me, how green is your building if you want to have a loan? And I will say, yes, my building is green. As usual, I have this label, this thing, these things. I am the best of the world. Look at my report that I did with my communication department. I am green. Doesn't fit anymore. You have to prove it, and who will check that you are green? The auditor's company. And the auditor's company, because they have a responsibility, will ask you to track the data you have given about the level of performance of your building. So this is what we call the double materiality. So it's quite easy. It means that the accountancy that was usually working and that are audited by auditors will be integrated with what we call the extra financial report, but it will be integrated into the report through this reporting about what is your green ratio asset. I am a bank, and my control authority, central bank, will ask me, what is your ratio of green assets in your portfolio? Whoa, I don't know at all. And this is the point, because we really need to know what is this green ratio asset, because thanks to 10 years of scientific research, we know that a green asset is less risky than a brown asset in use, in life cycle, and so on. So there is clearly a demand for the banks and the insurance to know what is this green ratio asset. So the taxonomy is the core of the system, but not only the taxonomy, because you have a list of carbon regulation in Europe. France is the world champion. I am very proud to say that. We are the first to have implemented the mandatory regulation on carbon life cycle assessment for new buildings. Yes, I'm very proud. It's a nightmare to do, but we can be proud of a nightmare. But clearly, we see that all other countries will follow up in Europe with Denmark, Finland, UK, even UK, which is not anymore in Europe, but it's very good friends, and they are following the best thing we are doing in Europe. And there we have a market requirement with an organized, standardized reporting system. And this is where the things are different, because they will ask in the taxonomy several indicators and what is the perimeter of calculation of these indicators and where we go. So we are back to this, what we call the Corporate Sustainability Reporting Directive. This is what is mandatory, and it will ask all the companies to give an information about their CO2 emissions and, of course, the building emissions. And in the taxonomy, you have climate change mitigation, which is energy use and greenhouse gas emission. And we have climate change adaptation based on circular economy, water use, pollution avoidance, and biodiversity. And this will be published by the end of the year to be implemented next year for the reporting. But I told you, when we're talking about greenhouse gas emission, we have two indicators. One is the embodied carbon. And we have two sources. The carbon from the building which is in use, heating, cooling, ventilation, appliances, the one embodied carbon. And embodied carbon is not nothing, yeah? Because we built every month, this is a report made by WBCSD, we built every month the equivalent of New York City, every month. So this is where your 40%, Céline, are in the building, new buildings, in countries which are developing very fast, and we built a lot of buildings. So it's not a matter to say that we don't have to do anything. It's just a matter to have the scales and where we have to have an impact. And in this report, we have worked, and we see clearly that the design optimization is one of the core requirements in order to go for low carbon. This is where you can take the decision and change the impact of your building. And then you can have this kind of life cycle approach, as I said, with life cycle greenhouse gas and life cycle cost. You see in this building, I put it because the worst product in this office building was the carpet tiles, because according to the data that I had from the provider, I had to remove the carpet tiles every 5 years, because the lifespan of a carpet was 5 years in the documentation. So I asked the provider what's going on. Oh, he said, yes, we said to change to 5 years, but we can easily tell you 25 years. And he changed the calculation, of course. So you see what is the reliability of the data, where the data is coming from, who is responsible about the information. So to give you an overview, we go then to energy in use, and this is the level of performance that we have to achieve for nearly zero energy building in Europe. So it's by climate, Mediterranean, Oceanic, Continental, Nordic. And you see that we have for offices and family houses and flats, the targets that are set. So clearly in terms of targets, if I'm in the Oceanic part, my primary energy use is something around 50 to 65 kilowatt per square meter per year, with a ratio that I have to implement of 40% of energy, renewable energy in. And this is clearly something that the European Commission wants to achieve by 2050 for all the building in Europe, not only the new. But this is the goal for the moment for the new buildings, and the goal is to go for all new buildings. So to do that, we have a set of standards. I will not go through. You know that. The idea is really to work with this set of European standards. And we also have a possibility to do it in a building passport or a logbook. So you have 50 years or more of use of a building. You can then use your primary energy consumption. You can have an information about the indoor quality, thanks to the European norms, again, that give you the class in terms of climate indoor. You can have then your design and embodied carbon, because we also have a norm of a calculation for life cycle assessment. You can have a calculation of your operational carbon. You can manage your uncertainty. You can work with a definition of surfaces, and so on and so on. So this is really where we need to go in order to have a visibility of a building. But at the end, what I would like to emphasize is we need this data not only to fulfill the requirement in greenhouse gas emission, it's also because this performance will have an impact on the value of a building. And this is the trigger. If you don't give information to an owner, or to a landlord, or to an investor about how to change and why should I pay, saying in other words, why should I pay more for a better building? If at the end of the day, I can't prove it, I can't prove that it has a lowest consumption or lowest impact in terms of greenhouse gas or a longer lifespan. This is where the work of data collection, data management, data tracking, reliability, accuracy is key. Because if we give all the information, then we can have a layer of IoT and services. You have a functional requirement. You can go to a performance contract about the building and not work anymore with design, with an iterative design, with I want a building this and this. You give a performance that you want to achieve, and the designers can work together with the industry makers, with a construction company in order to achieve the building. And it's a change also in the contract process, because we also need innovation thanks to the data with the contractualization and the law approach of the process. So it's also the possibility to work for life cycle assessment and life cycle cost. I show you the model. We now have in Europe what we call the eco-design, which is the new digital product passport. We have also the environmental product declaration, where you have information about the lifespan. So we can move to this kind of vision where you have the components of a building, the lifespan of the components, how it reacts to the system, because a building is not a Lego. It's not a toy. It's a system which is far away from the equilibrium. And this system needs to be managed all around this life cycle. And then you can plug this system of building into the infrastructure. You can plug it into the neighborhood, and it's connected with different scales from the components of a building up to the neighborhood. So my conclusion will be we clearly need data transparency to move to valuable information in order to translate the work we are doing on data collection, data quality, into the building quality, into a better valuation of a building. And a couple of years ago, I worked with colleagues from the United Nations, and we called it the translation from the boiler room to the boardroom. Because if you are technicians and you work about the quality of your performance, of your technical components, if you are not able to translate it into a risk approach, into a lifespan approach for the decision makers, it makes no sense. Because in the accountancy system, there is no difference between a good performing building and a bad one. The only difference is how it is rented and the level of rent, if it's an office building. So a very bad building, if it's well rented with a high level rent, will be the best in terms of accountancy approach. So clearly this is why I propose to work with you on data collection and translation forward to the decision makers. And then, if we succeed in that, the PSI can have a core action for the management of the standards, management of information collection, and management of the information translation. Thank you. And yes, you.
Thanks, Frank. I think Frank just presented us with a very big business opportunity for everybody here in the room, and also for accountants. Our next speaker has been working with Schneider Electric for 26 years, to her own surprise. She is currently the CTO for MEP software there, and earlier she was involved with building the largest solar power plant in Europe, at the time at least. She's leading our sustainability energy management room, and as the majority of the energy emissions, the emissions from the built asset industry come from the energy usage of buildings, her insights are extremely valuable. please welcome to the stage Trinidad Chardin-Segui.
Thank you, Céline, for the introduction. Bonjour tout le monde. Je pourrais faire la présentation en français, mais je crois qu'il faut que je le fasse en anglais. Donc, je vais malheureusement switcher en anglais pour ceux qui parlent français. So, my name is Trinidad Chardin-Segui. I work at Schneider Electric, and I'm very convinced that the importance of building an interoperability standard to allow sustainability in the building. So, as said previously, today, 30% of the global emission in this CO2 are coming from the building industry. So, just again, a concrete example. Today, it's equivalent to 29 round-trip flights from London to Los Angeles at full capacity. If we look at the efficiency, 30% of the construction work is inefficiency and waste during the construction and during the design. So, and last figure, if you look at our lives today, 90% of our time is spent indoors. So for us, building, it's very an essential asset for our lives. The building industry is part of the problem. And as you understood, we have a lot of opportunity to improve, and we should become part of the solution. So together here, what I invite you is really to be part of the solution. So if we look today at the climate change, we can still reach the 1.5 target. For that, we have to reduce 3 more CO2 emissions for 2030 as a reduction. So, very simple action to do. First, if we look at the actions, we have 3 main ones. As we said, we have to decarbonize the energy supply. So we have to move from fuel production to green supplies, renewable, such as solar, wind, hydro, biogas, is really a way to decarbonize the supply. The second is on the change the usages. The usages, most of them are linked to the to fuel system. We have to move from fuel heating to green heating pumps kind style of things. We have to reduce the consumption, and for that we have really to reduce the demand through an optimization and a management system of the demand. Oops, sorry. We have made a study, and in average we can really reduce 30% of the total emission in the building. And guess what? Looking more granularly, we can reach up to 80% abatement in the retail and the living buildings through a huge work on the building and the renovation. No magic, just we made models and simulated them. So we worked on 2 building configurations. That means 6 kind of buildings, single family homes, office, hospital, hotel, retail, and education. We have selected 2 scenarios: new construction, 30 years old construction. Second step, we selected 19 regions with different load and weather environment. Third, we work on 3 combined technology, moving from heat electrification, active energy management, and distributed generation. We compare years of payback and cost of acquisition. And finally, we tried 2 scenarios, one with the current CO2 emission and with the expected one for the 2030 scenario, using all the reduction of CO2 emissions that are expected in the regulations. Oops. If you want to have much more information, I invite you to download this document called Toward Net Zero Buildings. You can find it in the website of Schneider. You have a very deep detail of all the analysis, all the hypotheses, and how we made the study. Okay, and how? Now, what's the question? How we have to do that? And for me, how collective engagement is really to implement those change now. At Schneider, we are already doing that as a corporate company way of managing the company. We started 15 years ago. We are driving the company with 5 guiding principles. First of all, we are taking green engagement. And we are sometimes doing beyond the regulation. For example, we have some medium voltage product and we are banning SF6 from them, and we are going beyond what the regulator is expecting. We are taking engagement with all our stakeholders, from shareholders to the society in general. We have implemented ESG objectives as corporate commitments. And we have built our strategy to be the trusted advisor for our customer for sustainability and efficiency. Last, we are implementing our unique global model. Means that we are a global operating model, but we are allowing a lot of local integration through the R&D and the project. So just to give an example, we have 5 R&D hubs. They are all working to develop locally for product and their local market, but they are all globally working together for the global offers of the group. Thanks to all those actions today, we are ranked #1 last year, and we remain on the top of the most sustainable corporation company worldwide from Fortune 100. We are leading the sustainability by example. We have implemented, or we are implementing, all our products inside our facilities and factories. We are implementing all our energy and sustainability commitment through them. And we have, for example, we have built one of the most sustainable buildings, a LEED Platinum in operation for our R&D center in France, in Grenoble. We are helping our supplier to become more sustainable through a partnership program. And we are helping our customer being their digital partner. So we are inviting them also to enter in our factories, our sites, because we are using them as live labs and as showroom. They can really see the sustainability for real and in operation. Our unique value proposition is to help our customer to build their sustainability journey. So for that, we help them to strategize, means define the enterprise baseline, create decarbonization roadmap, structure and communicate on their commitments. The second, we help them to digitize, put in place and monitor, track, identify saving opportunities, report and benchmark. And third, through decarbonization, we help them to electrify, to reduce energy usages, to replace fuel, gas energy to green energies. And we help them also to engage all their value chain. Decarbonization and sustainability need good interoperability. Is the reason that we are convinced of the necessity to build a software ecosystem across all the life cycles of the industry, from design, build, and operation and maintain. Thanks to a unique software portfolio, we are offering that to our customers. And we are really convinced that to build more efficiency and sustainability, we need more interoperability in the energy and electrical model. We are actively contributing and pushing to create a new room, the Sustainability Energy Management Room in buildingSMART. We are bringing 15 years of expertise in the domain and bringing our normalized electrical model, in which we already invested more than 2 million euros to build it. And we are offering that to the buildingSMART community as a base ground to build this interoperability standard. So, with the members, and unfortunately they are not here presently, but you have the list behind. We want to enrich the IFC model with a new electrical model. We call it name as new electrical model or as normalized electrical model. We want this model to be the ground base for the electrical digital twin. We already want this model helps to build simulation model for electrical energy. We understood we need optimization. We need to exchange information on the electrical model. And we are propose also this model as being the base ground for calculation for the sustainability impact. So really, I work more than enjoying and inviting you to welcome us in this room, because it's very strategical for the sustainability in the future for the building industry. Thank you for your attention. If you want really to interact more with my colleague Tari and me, we are present in the event, and we will be more than happy to exchange, explain what we are doing and what we can bring on this topic.
Thank you, Trinidad. You gave such a concrete example of how standards can contribute to sustainability, and it's great to see a large organization like Schneider Electric being so committed to sustainability. Our next speaker knows a whole lot about green buildings. He's the Senior Vice President of the US Green Building Council. And he's leading a platform called ARC that measures the sustainability performance of buildings and spaces. Prior to that, he was involved in an organization that measures air quality. And he was also the COO of GRESB, which is another sustainability rating for real estate. We're very pleased to have you here. Please welcome Chris Pyke.
Guys have been here for a long time, so hopefully I can entertain you and inform you for a few more minutes before we have lunch. So a couple of things. So I want to talk to you about the drivers in my world. Yes, I do work in the green building space. I do self-identify with the built asset space. I'll tell you a quick thing or two about me is I am a card-carrying geographer. I got a PhD in geography. I worked on data schemas, databases, the ontology of land use, the ontology of wetlands. And I have spent the last 20 years working on aspects of the built environment, from literally the boiler room to cities and neighborhoods. So I want to bring you some of that perspective today. I want to tell you just enough about what my day-to-day job is to give you a sense of what are the experiences that inform the remarks that I'm about to give you. So first and foremost, I'm going to talk to you about something that is called ARC. So the first question would be, what the heck is ARC? So ARC is part of the US Green Building Council family of organizations. Our partner organization is the Green Business Certification, Inc. We work globally. So just last week, completed certification of 100,000 certified projects. Those occur in more than 180 countries around the world. My particular operating unit is we're a small for-profit subsidiary of a nonprofit. That may or may not make sense to you. But what we do is we measure, track, and score the performance of spaces, buildings, and places Recently, we passed through 7.2 on our way to 7.3 billion square feet of space in 141 countries. So I offer that to you, that's what my day job is. So the key point, but our mission is this. So resonating with what Céline said, what Frank said, what we've heard a number of times, our mission is to advance a built environment that is better for people and the physical environment. We understand that we are pursuing some version of this IEA roadmap. And the reason I have this up for you is that when we really boil it down, to achieve our Paris-aligned goals, to achieve to avoid the worst impacts of climate change, we are talking about essentially completely decarbonizing the built environment by 2050, a 97% reduction. And what the IEA tells us is there is no silver bullet. To do this, we are looking at a combination of behavior, efficiency, fuel switching, electrification, and more. And ultimately, if you boil it down, I'm pretty much on board with this Schneider vision: clean, efficient, electrified, and grid responsive. And critically, in an era where we are really worried about greenwashing and concerns about, are you doing what you say you're doing, that performance is ultimately verified in operation. So the implications of that for those of us who care about data and data interoperability are the following. So achieving those outcomes requires, what we're seeing is an emerging ecosystem of tools and interoperability requirements that are required to achieve that IEA roadmap or any of dozens of other comparable roadmaps. What we're trying to look at is a set of goals and targets that are aligned with that broad roadmap, a set of actionable plans for every single asset. I'll tell you what I mean. Core actions that stem from those plans, and align performance metrics. Each of these sounds easy in isolation. Each of these is harder in practice, and all of them are harder to do millions of times over, which is what we're talking about. So this is the world that I see emerging, and I think in many literal ways it is adjacent to many of the worlds you live in as BIM professionals or as folks who are in the open BIM community. We are certainly connected by open data concepts. So what I want to talk to you about is a world where we see a proliferation of goals and targets. You heard a bit about that with Frank, but he only scratched the surface. We see a proliferation of plans. Ultimately, that proliferation is going to result in millions and millions of plans, and a proliferation of actions, we'll talk about that, and a proliferation of performance measures. Let's start with goals and targets. So if we go back 5 years, we understand that our big global goal, that Paris Accord aligned to avoid exceeding 2 degrees Celsius warming. Now, how are we actually doing that? We are doing that on a global basis through what really amounts to a bottom-up effort. We have local governments, places around the world establishing a universe of climate action plans, a universe of targets for what it means to hit their decarbonization goals. If you want to talk about the implications of this as a policy structure, I want to go have a beer and we can talk about this as a policy structure. But what I'm giving you is the empirical reality that whether you are in Canada, whether you are in the US, the EU is its own special thing. Whether you're in Canada, whether you're in Australia or China or around the world, we see a groundswell where we see hundreds and thousands of jurisdictions establishing their own decarbonization journeys. And what that means to you is that those jurisdictions are establishing different expectations for building performance that fit their circumstances. And if that wasn't enough, we have hundreds and thousands of organizations ranging from the S&P 500 to the more than 6,000 publicly traded companies around the world, each establishing carbon targets, renewables targets, science-based targets, which we heard a little about earlier. So we have a world of plans. And Here's the hitch. So today, those plans cover 26% of the global population, and they all look something like this. Actually, I wish that was actually true. They all look something like this. They represent a goal or an aspiration to move down in greenhouse gas emissions from whatever the jurisdiction is incrementally over time. The problem is they don't specifically look like that. And when we go to try to establish what we ultimately need to be able to do is have an interoperable framework where when someone in Montreal creates a performance standard and someone in Washington, D.C. tries to analyze a corporate real estate portfolio that is subject to Montreal standard, Vancouver standards, the Paris standard, the one in London, is we need a framework to be able to understand, exchange, and update this universe of standards, and I guarantee we don't have that right now. So what is in that standard? We need to understand the authority. Is it a local government, a state government, a national government, a corporation? What is the geographic scope? What items are covered? Big buildings, small buildings, old buildings, new buildings. What exactly are the thresholds? What is the structure? Does it have a stair step? Does it ramp? And what exactly are the performance metrics? Primary energy, greenhouse gas intensity. Do you normalize by something like occupancy? All of these exist. Are there financial penalties? If so, how and why? Okay, we have been doing this. And I can tell you that we need this collectively. Otherwise, we are literally and figuratively creating a Tower of Babel about goals and targets that will be both difficult to build and impossible to sustain, which sounds like everything in the open data and open BIM that we are against. Okay, so traveling downhill, we have a universe of plans. And I'm gonna be a bit controversial. I think that I love what Frank said about those goals and targets in Europe, but I actually think that ultimately we're gonna look back and go, I think that stuff was not exactly the right idea. We are in an era where we are benchmarking buildings against what amount to arbitrary energy intensities and arbitrary greenhouse gas emissions intensities. What we need to do is get to a place where every asset has a clear, concise, and actionable plan for decarbonization. Because achieving the IEA targets mean we don't get to leave any buildings behind. That 97% reduction is every building. That doesn't mean you get to pick and choose the green ones. So this conversation in Europe about where the line between green and not green in, just to use a technical term, is stupid. It is because ultimately every building has to get better. Every building needs a plan, whether you are green or not green. And the question is, what's in that plan? So we see organizations like this happens to be the University of Pittsburgh. University of Pittsburgh is making an awesome climate action plan that covers hundreds of buildings. Great. Okay, it is very pretty. It talks about here's my baseline year, here's the growth in my physical estate, here's my demand reduction, here's my supply reduction, here's my low carbon connections to the grid and all that kind of stuff. That's awesome. It looks good, it feels right. But as a data exchange issue, what are these boxes? What's in them? What do I connect them to? What is in my database? What am I exactly getting out? And how come the University of Pittsburgh Climate Action Plan, which covers, I've circled all the things that are essentially data elements, and obviously I'm just scratching the surface, but how do I compare it to the one for McGill, or the one for UC Berkeley, or the one for the University of Chicago? Whatever right now, the answer is not. Every plan is a bespoke snowflake. Some of them are excellent, like this, and some of them are laughable. Okay, so how do we get toward an ontology of plans so that when someone tells you about a plan, you can understand its core and essential attributes? What is the entity we're talking about? The University of Pittsburgh. What are the assets in that plan? Individual educational buildings, maybe the central plant, maybe the horizontal, maybe that's in, maybe it's out. How do I know? What are the targets? What are the timelines? What are the actions? What do they mean? What are you talking about? And what are the performance metrics? That's all in the plan. And right now, it's choose your own adventure. You get to do whatever you want. That's both noble and bad. All right. Ultimately, those plans specify actions. We all love actions. Actually, I think we love actions not enough. I work for an organization that is dedicated to measuring performance. At the same time, we understand that it's important to have a vernacular of actions. In a way, IFC gets us close. We have a vernacular of stuff, a vernacular of features, a hierarchy of things. But when we look in those plans are saying actions. They are saying increase energy efficiency, do an audit, work on the chillers, retrofit the lights. Now, here's the thing. We could call those energy conservation measures, sustainability strategies, optimizations, recommendations. We call them all those things. But we don't have a clear and accepted ontology of those actions. Let me give you 3 basic examples. So there's a grand model that JCI supported coming out of Lawrence Berkeley National Lab. It gives data-driven recommendations for portfolio-wide energy improvements. Okay, what does it look like? It's that thing on the left. It says, I looked at your portfolio. I recommended you reduce lighting loads, you reduce lighting and plug loads, you ensure adequate ventilation, reduce equipment schedule, and reduce equipment schedule. Okay, great. What are those? What are those exactly? Okay, I can go to ASHRAE level 2 and line those things up, and I can say, upgrade lighting to low-emitting diodes. Great. LEDs, wonderful. I can install some occupancy sensors. Great. That gets more specific. That's at least a thing I can buy at Home Depot, but I don't know how many I bought. I don't know what kind I bought, and it's not quite specific enough. On the right, I have LEED standards for a reviewable set of interior lighting requirements. This is fully reviewable to the point that causes some of your stomachs to churn. So it has specific thresholds, specific documentation requirements, and we know exactly what we're talking about, and it only embraces a fraction of the actions we want. So the bottom line is, if plans are specifying actions and the accountability for actions getting done requires us to know what we're talking about, we need to begin building an ontology of actions and having a language where if you're saying one action, I know what you're talking about. Again, it sounds like our universe. The last one of these 4 categories is ultimately performance. And you would think this is the easy one, because didn't we hear earlier that everybody's got these performance measures, whether it's EUIs or GHGIs or something else, and that's great. And we do the same thing. For all of that 7.5 billion square feet that we track, we measure primary energy, greenhouse gas emissions intensity, potable water, waste diversion, waste generation, occupant satisfaction, and different measures of IEQ. Yay! However, we do it for a lot of projects, but we don't do it the same as you might do it. and the devil's in the details. So the good news is lots of you have been focused on the ontology of performance. The bad news is lots of you have been focused on the ontology of performance. So whether you are at Lawrence Berkeley National Lab, or you're in the Australian government, or you're at the US Energy EPA, or you're us, or you're Oscar, or you're someone else, we're all doing this differently. The good news is we recognize the challenge. The bad news is we've got multiple ontologies and they are very difficult to crosswalk. Okay, so we do this all that we know this is possible because we do it. We know it's a pain point because we live it. We feed data from 20 different partners all around the world, including our colleagues at Schneider. We pass it through our system. We give it to independent reviewers, and then we score it in real time. So I'm speaking to you from the back of someone who runs that platform. All right, so let me begin to bring this plane in for a landing here. So ultimately, everything I've talked to you about is for the purpose of this roadmap. Getting to something that looks like a clean, electric, grid-responsive, decarbonized vision for the built environment. We really have no choice. As Céline showed us at the beginning, we have societally no choice but to do that. To do that, what seems to be emerging in my corner of this built asset world is the need for a new set of ontologies that help us go from the constructed world that many of you are intimately familiar with to the world of real, delivered, target-aligned information. That will require an emerging effort all around the world to develop a vocabulary, an ontology for goals and targets so that I can understand you, I can maintain, update, synchronize these expectations when we're working across dozens or hundreds of countries. We need a language to be able to share plans in robust and reproducible and ultimately verifiable ways. I need to be able to look at a plan and understand if it is what it is saying in a clear and transparent language. I need to understand the actions in that plan in a way that I can verify, or in the language of buildingSMART, certify, and ultimately do the same for performance. So if you're interested in the things I've talked to you about, you can certainly explore our work. I'd be excited to talk with you about any of it, and I'm looking forward to the rest of the conference. Thank you.
Thank you. Thanks, Chris. Well, you put us on the right track. I just couldn't help but wonder about your own house. That must be very sustainable, I guess. Right? We heard a lot about how buildings influence the climate, but not so much yet on how the climate influences the buildings. Our next speaker has published several research papers on how to adapt cities and buildings for climate change. And she has also developed a tool to assess climate risks. She's an architect, and she's a sustainable development advisor at the Société Québécoise des Infrastructures. Very pleased to have you here. Please welcome to the stage Catherine Dubois.
Thanks, Céline. Thanks, everyone. I'll be a tough challenge speaking after Chris that was very dynamic. So brief, this is the plan for the next 20 minutes, maybe a little less. Everybody's getting hungry. I will start with a brief presentation of the Société Québécoise des Infrastructures, which will be called from now on SQI, that I represent today. Then I will answer the following question: what does climate change really means for real estate managers? I will continue the presentation by discussing the opportunities and the challenges of open data. And I will end by offering you a quick look into the tool that I have developed in the recent years to assess the climate risk of our buildings. So SQI's, the SQI's mission is twofold: to support public organizations in the management of their infrastructure projects. We're talking about hospitals, houses for the elderly, for example. We have lots of projects of that kind. And to develop, maintain, and manage a real estate that meets the needs of ministries and public agencies. So here's a little quick look into our portfolio. It includes about 350 buildings that are located throughout the province. So just to give you an idea of the territory, we're talking about 4 times the size of France, just the province of Quebec. These buildings were built at different times, play different functions for the Quebec society. So we're talking about police stations, courthouses, laboratories, transport facilities, office buildings, just are some examples of our building stock. So what does climate change really mean for real estate managers? First, property loss and damage. This picture shows the consequences of a severe wind gust that hit one of our buildings in 2018. Damage can also be caused by heavy rainfall, which can trigger either urban or river flooding, and by snow and winter thaw, which can compromise the structural integrity of our buildings. These climatic hazards represent a significant threat to the building occupants. Second, to us real estate managers, climate change means more power outages. So ice storms, wind gusts, and heat waves can all threaten the electrical supply of our buildings. And although many of them are equipped with a power generator, very few can actually are ventilated, heated, and can fully complete their operations in the event of a power outage. Therefore, these events pose obvious problems in terms of occupant comfort, but also in terms of public service delivery. And third, with climate change, real estate managers should expect premature weathering of certain building components. Stone, brick, concrete are sensitive to freeze-thaw cycles. So are various membranes and sealant that don't like UV rays when combined with warmer temperatures. In addition, freeze-thaw cycles allow ice to accumulate on walkways around buildings. If these surfaces are not cleared enough, they can lead individuals to fall and suffer from minor to moderate injuries. So in short, for real estate managers, climate change means at the building level, property loss or damage, premature weathering, slowdown of operations, power outages, and building system malfunctions. At the occupant level, the risks are mild to moderate discomfort, minor to serious injuries, intoxication, psychological impacts, and even death. So these risks are, of course, just to be cheering, interrelated. I will also add that climate change represents a wicked problem for real estate managers. In terms of scale of action, they are usually concerned with the building and its site. And as for the time frame, they usually look at the present day and the midterm. But climate change calls for a change in practice. Real estate managers have to extend tremendously their scale of action in order to encompass both territory and climate. And they also have to adopt a long-term vision for their portfolio. At last, they have to learn to work with a great deal of uncertainties. Nobody knows exactly how the climate will change, to which extent, and under which frequency. So it's okay to feel a bit of anxiety with that climate change. Luckily, nowadays, the abundance of open data available represents an opportunity to tackle the complexity of climate change. The opportunities and challenges will be discussed briefly. Yes, open data can support change in practice. Information about our changing climate and how it may interact with our territory is available on the web. Real estate managers have to learn now to work with this new level of information and figure out how it can complement the digital information they already possess in their databases. But open data is not all when it comes to assessing climate risk encountered by existing buildings. Firstly, not all plans of these buildings are available in a digital format. Secondly, our databases, especially the fields regarding the overall condition of specific building components, such as roofing, the building's caulk, sealant, they're not necessarily up to date. That is why the assessment method that I have developed rests on workshops to bring together the staff that is responsible for the maintenance of a particular building. In other words, we still need people. The knowledge and the experience of our teams out in the fields are valuable assets in the risk assessment process. So now let's take a quick look into the tool. I'm very humble. I've seen the presentation of Dassault and Autodesk. This is a spreadsheet. So this spreadsheet we use to assess 7 climatic hazards: the wind gust, urban flooding, river flooding, heat waves, freeze-thaw cycles, snow and winter thaw, and at last, ice storms. The tool is not attached to a building information model, but makes use of several digital data. So we call climatic data both historical, the data that have been observed, versus projected climatic data, what we expect, architectural drawings, architectural data, building footprint, window to wall ratio, number of stories underground, number of stories outside, photographies, technical information about our system, plumbery, heating, ventilation, air conditioning, geolocalized information about the site, the territory. Are there any risk of landslides? Are there any risk of flood, for example? And several information found on the web. The cross-referencing of all these data allows the tool to calculate 2 indices. the Climate Change Contribution Index, and the Overall Climate Risk Index. Moreover, a table and a pie chart allow examining individually the result for each hazard that have been analyzed. This allows identifying the risks that should be addressed in priority for that building. The tool also produces 3 summary tables. They are intended to identify site and building elements that should be the subject of future work in order to both reduce greenhouse gas emissions and reduce risk by diminishing the overall vulnerability of the building and its site. These results will be complemented with adaptation guidelines that are currently being developed. So I thank you for your time and your attention.
Thank you, Catherine. You showed us some climate risks that I wasn't aware of yet, but also some opportunities again for us to see what we can do with data around that. Our next speaker takes sustainability very seriously, so seriously that he is doing his presentation online from the Netherlands. He's a board member of buildingSMART International, and he is a director for BIM and digital engineering at Royal Haskoning, DHV, which is an international engineering consultancy firm. He's very passionate about sustainability, as I told you, but also about innovation. Please give him an extra hard applause. Welcome, Jugal Makwana.
Thank you, Céline, for the kind introduction. And sorry that I can't be there. I do take sustainability seriously, but that's not the only reason that why I can't be there. But I'm happy that I can still share this with you virtually. So today I thought we've heard a lot about sustainability and lots of fantastic initiatives which my earlier speakers shared. And I thought I'll focus on our approach on digitalizing sustainability. So the presentation that I have prepared is focused on 2 aspects. One is sustainability and how we see sustainability. What are the aspects of sustainability? And the other is the approach towards digitalizing some of the components of sustainability. Again, this is just a snapshot of what we're doing and what the potential of digitalization, not very comprehensive. It would take hours for me to talk about everything, but I thought it's still good to share how we see sustainability and the digitalization aspect of it. Now, before I start, I'm sure many of you would have seen this image. Now, this is our doing in terms of what we as a society have done to our earth and climate over the last 170 years. So this, each of these bars that you see are global temperature deviation from the mean over the last 170 years. So on the red ones are very recent on how those temperatures have been rising and the impact that it has had on our climate is significant. And although we have been doing things to mitigate that for last 40, 50 years, but still we haven't been able to control it. And this is what we call sustainability, our effort to minimizing the impact that we have on the climate and everything else. But this is, from our perspective, just one aspect of it. So climate change or mitigating or managing that climate change is one of the aspects of sustainability. There are, although, other aspects like biodiversity or putting in effort to sustain the biodiversity that we have for our well-being. Resources. Now, we as an organization, we as a community, which is the architectural, engineering, and construction community, I'm sure Céline talked about the resources that we consume and the impact that we have. So those resources, we should be mindful of how we do it and embed the principles of circularity and optimize that as well. The other aspect that we also look at in that context is social value, inclusion, and diversity, and the inclusivity that we can bring in within our community and our stakeholders and everyone else. And last but not the least, focus on safety. And these are the themes that are an integral part of our purpose, which we call enhancing society together. So sustainability is not just about climate change, but it is about these themes. And all the projects that we do, our aim is to make a positive impact on those projects in each of these themes. So recently we started measuring our impact on these projects, and also looking at how can we mitigate or minimize the impact that we have on climate, biodiversity, resources, and safety, and everything else. And this is what is our purpose. So at Royal Haskering DHV, 6,000 of our colleagues working on projects in 100+ countries are dedicated towards enhancing society together, focusing on those projects and making difference one project at a time, and ensure that we become a future-ready consulting engineer. We have, last year we celebrated 140 years of our existence. So the question is, okay, how can we sustain that? How can we contribute further to the society and make our society future-ready and make ourselves future-ready as well? In that context, digitalization is one of the key components, or one of the key enablers that we see in realizing our purpose. And over the last few years, we have done a lot of things in digitalization. One of the key pillars of digitalization is what we call our Digital Ways of Working program, which is around embedding a more data-driven working, modernizing the way we work, moving from a document-driven organization to a data-driven organization. And in that context, also leveraging technology, packaging our domain expertise of 140 years into technology, so that we can pass on the benefits to the client and to the society, and also help our client in their own digital journey. And this is what we say, that preparing ourselves to becoming a more data-driven engineering consultants. Now, again, in digitalization, there are lots of areas that we focus on. So some of the key themes that we focus on is, one is obviously BIM, information management and information modeling, where openBIM is one of the key principles of our approach. Geospatial information system, because we work in the real world geospatial context, and we need to understand with all the information that we have, connect that information to derive value out of that information. And third is also look at data science and data analytics, how it can help us in some of the challenges that we have around understanding the data that we get from these various sources, packaging them, analyzing them, and looking at what more can be done. Fourth is, as I said, we want to move away from being a document-driven organization to a data-driven organization, looking at how can we engage with our stakeholders, with our give them interactive digital reporting mechanism where they're able to share and see that data and the information. And last but not the least, one of the core theme is also what we, let's say, you've heard of a lot of things on augmented reality, virtual reality, mixed reality. So how to maximize the potential of these technologies on our projects to improve safety and things. So each of these themes have a key role to play in our approach towards enhancing society together and sustainability. And I thought I'll share a few examples with you, which are quite interesting in the value that they bring. So when we talk about information management, information modeling, and BIM, sorry, it is the value of information is about how we use it, what we do with it. So this is one of the examples of a revetment project where the team actually put in a lot of effort to look at how can we optimize and minimize our carbon footprint on that. What are the things that we can do differently? So they generated lots of options, and in that figured out that, okay, if we have a revetment with a crown wall, then that, although is higher in cost, has a significantly lower CO2 emission. So to an extent that 15 ton, or in total of 1500 ton lower for a 100-meter section. Now, again, this is an infrastructure example, right? So you would have seen a lot of building examples. So I thought it was interesting to share this. Now, what does 1500 ton mean? Céline shared some of the earlier statistics, what it really means. So 1500 ton means that all of you who were there probably could fly to Amsterdam and back twice with that 1500 ton of carbon emission. So there is a significant value and savings that we could analyze and offer on our client and help them optimize it. So this is one such example of the things that we do on carbon footprint calculation. We have lots of other initiatives which are in pipeline, again, with the ambition that we help our clients and our projects to mitigate it. This is another example on how, let's say, geospatial technologies were leveraged to optimize on biodiversity and to be more conscious on what we are working with. So this is in Manila Bay, where there are mangroves. The development was surrounded by mangroves. So we had to be conscious of what we can do. So in this context, the team put together all the open geospatial data available in an interactive map, analyze it on that biodiversity aspect, and then see what is being impacted and what needs to be done to minimize that impact in that context. This example on is connected to resources, but not the only one again, where the team in this case looked at how can we optimize our commute to work, mobility. So we have 3,000 colleagues in the Netherlands, and we have several offices in the Netherlands. So look at, okay, what is the most effective way of commute and transport? If they come by, let's say, car or bike, what are the alternatives? What is the consumption of resources, in this case, fuel? And how can that be further optimized? This is a combination of open data, geospatial, and a lot of data analytics, which enabled us to do this. Again, there are lots of other examples where we're also trying to see how we can optimize on material, right? So the raw material that we have, how to optimize that, how to bring or minimize the consumption. How can we use some new advanced materials or recycle material and induce the concept of circularity in that? This is an example around the aspect that we talk about social value and inclusion. So from a digitalization perspective, over last couple of years in COVID, the projects had to continue. We had to communicate and connect with our stakeholders and our clients. And this is what we do through an interactive report, which is a medium where anyone in the community or the society can look at what is the offering, what is being proposed, how their lifestyle or how their lives would be impacted by a certain initiative, whether it is a new road or a new rail or a new apartment or building nearby. What are the things that could be improved? So to include those stakeholders in the design process, we have this interactive report where they were asked to share their ideas and thoughts, which was collated in what we call a common data environment in that context, and then further work on improving it. So make it more inclusive. And last but not the least, around safety. Now, safety is, there are lots of areas. Obviously, we can work on improving the physical safety, but how can we use digital tools and technologies to improve safety? And in that context, we looked at, let's say, augmented reality, virtual reality, mixed reality, to look at or simulate our built asset virtually before they're actually built, to see how they would perform. So this is an example of one such project which we did with WaterNet. The BIM manager of WaterNet is also sitting there. You can obviously ask him more on this, and some of my colleagues are there who can also share details on this and other projects. So this is an example of a simple bridge which we designed, and the information model or the BIM model was then put into, in this case, an HoloLens, and everyone went to the site to see how that works and simulate the environment to understand, would it work fine? What are the likely changes that need to be done in the design, to iterate that process and work collaboratively with our clients and the stakeholders again to look at it. So the same, I'm sure you would have seen several initiatives on how virtual reality and augmented reality are being used on construction projects to improve safety on those sites. So this is one such example of that. So as just to summarize, we have lots of areas where we see digitalization adding significant impact and value to our ambition of enhancing society together and sustainability. And it all revolves around data. What we can do with that data, open data, is an integral part of everything that we do. So this is a brief take from our end. Thank you very much. And I won't stand between you and your lunch. So enjoy rest of the summit. Thank you.
Thanks, Jugal. So 1,500 tons of CO2, that's also about 5 buildingSMART international summits. So with that, I want to announce the lunch break. You can find the lunch on the 4th floor, but before you go there, please check out the 3rd floor, where you will find the booths of our sponsors. Enjoy your lunch. Thank you.